In this video, we're looking at trapezoids, part 1 of our notes. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So let me make a sketch. We have one pair of parallel sides on each of these two figures here. Now an isosceles trapezoid is a trapezoid where the non-parallel sides are congruent. So I have one pair of parallel sides, the other pair is congruent, and those are called the legs. The parallel sides are called the base, and there are two pairs of base angles. So the isosceles trapezoid angle theorem states that the base angles of an isosceles trapezoid are congruent. So there are two pairs of base angles. Both pairs are going to be on each of the parallel sides. As you can see here, the blue and the green pairs. Okay, example 1. Look at trapezoid TRAP below. What is the measure of angle A if angle T is 115? Well, we know that base angles are congruent, and we know that these consecutive angles, angle T and angle P, will be supplementary because they're same side interior angles. So I know that angle T and angle R are going to be equal. And I know that angle T and angle P are supplementary, so I can solve for angle P. And if I know angle P, then angle A is also a base angle. Then angle A is also 65 degrees. So I found all four angles, even though it only asked me for the measure of angle A. The isosceles trapezoid angle theorem converse states if a trapezoid has congruent base angles, then it is an isosceles trapezoid. So if we know the base angles are congruent, then it is a isosceles trapezoid. The non-parallel sides will be equal. Okay, the isosceles trapezoid diagonals theorem states the diagonals of an isosceles trapezoid are congruent. So I'm going to draw an isosceles trapezoid, one pair of parallel sides, and the legs are congruent, and the diagonals AC and BD are congruent. The mid-segment of a trapezoid is a line segment that connects the midpoints of the non-parallel sides of a trapezoid. So I'm going to make a trapezoid here. The midpoints of the non-parallel sides, and then I make a line segment between them. Okay, so let's take a look at this little investigation here of the mid-segment property. Draw a trapezoid ABCD given these coordinates. Okay, part 2. Find the midpoint of the non-parallel sides and label them E and F. So I can use the midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2, to find the midpoints. And I'll do this for the segment AD. So I'll make the substitution here, -1 plus -3 divided by 2, and 5 plus 1 divided by 2. And I get points -2, 3, as I'm labeling here. But you can also find this visually. You can see that we have to rise up 4 units and over 2 units to get from D to A, and I can just take half of that to find the midpoint. So I'll just find it visually here between B and C and find that my coordinate is 4, 3. For F. So E is -2, 3, F is 4, 3. Part 3, connect the midpoints to create the mid-segment. So segment EF is the mid-segment. Now let's find the lengths of A, B, E, F, and C, D. So A, B would be 3 units. C, D here is 9, just counting them straight horizontally across. And E, F would be 6 units. So I hope you see the connection here between these three, that EF is AB plus CD divided by 2. So you can see that 3 plus 9 divided by 2 would be 12 over 2, which is 6. So our mid-segment theorem is the length of the mid-segment of a trapezoid is the average of the lengths of the bases. And there it is. So we're going to use that idea in example 4. We're going to solve for x given that these figures are all trapezoids with the mid-segment shown here. So x in this case would be 12 plus 26 divided by 2, which is 19. In part B, 24 is given as the mid-segment, and x is one of the bases. So I need to set it up a little bit differently this time. 24 equals x plus 35 divided by 2. Multiply 2 to both sides to get rid of the fraction. Subtract by 35. And I get x equals 13. So if I were to check that, 13 plus 35 divided by 2 would give me 24. Part C, I have two unknowns here. Again, we're given the mid-segment is 20. And I need to take the two bases, which I'm given expressions here, add them up and divide by 2. So let's combine like terms. 5x plus 2x is 7x, and negative 15 minus 8 is negative 23. I can still multiply by 2 to both sides to clear the fraction. 40 equals 7x minus 23, add 23, and then I need to divide by 7, just simple algebra. 63 divided by 7 is 9. Why don't we go ahead and substitute 9 in for x in the problem so we can see if it works. 5 times 9 minus 15 is 30. 2 times 9 minus 8 is 10. And 30 plus 10 is 40 divided by 2 is 20, which is our mid-segment, which checks. So this is part 1. Hope this makes sense. If you get this, go ahead to part 2 where we talk about kites.